Hello class, I'm so glad that you could join me today for our first virtual lesson. I hope you are all doing fantastic. So in order to start, I'd like you to take out the papers that I gave to you. The first one is going to look like this, just a plain paper with a graph on it. And the next paper I'd like you to have, up at the top, it's going to say Unit 2 Quiz Review. All right, now that we have that out, let's go ahead and get started. What we're discussing here for the end of this unit is something called projectile motion. So projectile motion. Projectile motion has to do with objects being launched into the air and then coming back down to Earth. So we could imagine maybe a baseball being tossed into the air and landing on the ground, or somebody jumping off a diving board and landing into a pool. So the first thing that we want to do is label our axes. So we always have our horizontal x-axis and our vertical y-axis. For every problem we're going to encounter with projectile motion, we want to say that our x-axis is time. And then we can say that our y-axis is height. So we're looking at the relationship between an object's height and the amount of time that has passed. The first thing that I want us to do is identify the starting point of the object. So we know that at the origin of our graph, it's 0, 0. That means 0 time has passed at this point. We want to look at the height of the object at the very beginning of when we're starting to measure the time. This is what we call a y-intercept. And our y-intercept is this point here, and it's given by 0, y, because we know the time is 0, and the y value is going to be our height. It's going to be different for every problem, but in general, that y value is always going to be the height the object started at. If the object is being thrown up into the air, eventually it does have to land somewhere. So naturally, we might say that the object follows this path and then lands on the ground here at this point. So at this point, we're going to call this the positive 0. And that's going to be given by a point x, 0. And x is going to tell us the time the object hits the ground. So basically, how much time did it take for the object to hit the ground? And notice our point is always going to be x, 0. X could be any number. It's going to change for every problem. But our y value is always going to be 0. If we're on the ground, we have 0 height. The object hits the ground at our positive 0. But if we look back over here, we see the object hits the ground here. Let's call this our negative 0. So mathematically, a negative 0 does exist, but in the real world, it doesn't really make sense because this is saying in negative time, the object hits the ground. So kind of like time travel. We know that that doesn't exist in the real world, so usually we can discount this. So we can ignore this for most problems, because in most problems, it won't make sense to have negative time. Okay. Next, let's take a look up at the top, this point up here is going to be our vertex. And our vertex is going to be given by a point x comma y. The x value of that point is going to be the time the object reached its maximum height. And then the y value here is just going to be the maximum height. The last thing that I want to make note of here is something called the axis of symmetry. So that's going to be this dotted line. Anytime we're working with projectile motion, we're truly working with a parabola. Parabolas are always symmetrical. So that means this distance from the -0 to the axis of symmetry is the same exact distance from that axis of symmetry to the +0. It's always symmetrical. So that dotted line, that axis of symmetry, is right in the middle of this parabola. So also that means that the vertex is right in the middle. Let's move on to our next paper. So on our Unit 2 quiz review, let's look at this first problem. We're standing on a 336-foot tall hill, tossing a baseball. The baseball is thrown upward, and the function below models the height of the baseball in terms of the time since the baseball was thrown. So we're given a function here, and we want to go ahead and find out when does the baseball hit the ground, what was its highest point, all of that good stuff. So before we can do any of that, we have to factor this function. We have -12 t squared plus 36t plus 336. All right, in this class, anytime that we factored anything, we wanted to make sure that t squared was by itself in the front. So right now we're having an issue. There's this -12 in the front that we want to get rid of. So in order to do that, I can just divide every term in my function by -12. So let's do that now. We're trying to get rid of that -12, so we're just dividing it out. Then we'll be left with t squared. 36 divided by -12, well, that's going to be -3. And then 336 divided by 12. So we can use our calculator for this. I'd encourage you to use Desmos here. So let's load up Desmos. 336 divided by 12, that's 28. But let's make that a -28, so -28. Now that I just have a t squared out in front, I can factor this function. So I want to look at the number at the end, -28. And I'm going to make a list of everything that multiplies to that. So -1 times 28. -2 times 14. -4 times 7. And I think that's it. What we're trying to do here is add up to -3. We want to add up to that middle number. So I know -4 plus 7, that's +3, but we wanted -3, so we're going to have to play around with the signs here. What if we made this a +4 and we add it to a -7? Now all of a sudden we add up to -3, that's the number we wanted. So the factors we're going to use are +4 and -7. So let's write out our factors. +4 and -7. Okay, in our next step, we want to solve for the zeros. So I'm just going to take my answer from before and set it equal to 0. So when I set something equal to 0 that has parentheses like this, I'm going to take each part separately and make it equal 0. So t plus 4 equals 0, and then separately t minus 7 equals 0. And I want to solve those. So to get t by itself, I can subtract 4 from both sides. The 4 goes away, and we're left with t is equal to negative 4. On the other equation, we can just add 7 to both sides. The 7's go away, so we get t is equal to positive 7. Now, let's take a look back to the problem. We're talking about the time that a baseball hits the ground. T is time here. So let's look back at our problem. T is the time. So this is saying negative 4 seconds and positive 7 seconds. In the real world, it's nonsensical to talk about a negative amount of seconds. So really, we're only focused on the positive amount of seconds. What we have found here is that it took 7 seconds for the baseball to hit the ground. If we have a baseball here, it's starting here and then it lands on the ground, it's going to land here after 7 seconds. The other answer we found, negative 4 seconds, we don't really care about that because it doesn't make sense in our situation. Okay, now we want to identify the maximum or minimum point. So basically, what's the maximum height of the baseball? So looking back at our graph that we had from earlier, we know that our maximum point is here at the vertex. That's going to be our maximum. And I said that the vertex lies on that dotted line. That's the axis of symmetry. It's the exact center. It's the exact middle. So that means this amount of seconds is the same as this amount of seconds. So if we can find the distance between the negative 4 seconds and the 7 seconds and find the exact middle point, that will tell us this x value here. So let's try that. In order to find something exactly down the middle, halfway, we can add them together and divide by 2. So we're going to take those two answers from earlier. Let's take the negative 4, add it to the positive 7, and divide by 2. So negative 4 plus 7, and then we're going to divide it by 2. So that's going to be 3 over 2. And just for fun, let's make that a decimal, 1.5. So what this is saying is this point right here is actually 1.5. Well, any t value we have, it's an amount of seconds. So we're looking at 1.5 seconds here. Let's refer back to our problem. This means that it took 1.5 seconds for the ball to reach the maximum height. And if we want to talk about our answer from part B with the 7 seconds, we could say that the ball hit the ground after 7 seconds. Alright, so we were already able to find all this information just from factoring that function from earlier. Okay, so we know how long it took to reach this middle point. What we don't know right now is what this maximum height is. What is the height at this point? In order to figure that out, we're going to have to plug in the number of seconds into our function to get us the height. So our function here is negative 12 t squared plus 36t plus 336. That tells us the height. So remember, our y value is our height. If we plug in 1.5 for t, those 1.5 seconds, we can get our answer. So negative 12 times 1.5 squared plus 36 times 1.5 plus 336. We can go ahead and plug all of that into a calculator. Let's go to Desmos. Negative 12 times 1.5 squared. Then we're going to add 36 times 1.5. And then we're going to add 336. 363. So 363. We're talking about height here. Our problem uses feet. So what this is saying is that our height here is 363 feet. So we can actually add to our sentence here. It took 1.5 seconds for the ball to reach the maximum height, and we can say that the maximum height is 363 feet. Okay, last thing we want to look at is the line of symmetry. So that line of symmetry is that red line down the middle, the dotted line. Anytime that we want to give a vertical line, the equation for a vertical line, it's just x equals, or in this case, t equals, because we're using t instead of x. So it's as simple as taking the time from earlier and saying t equals 1.5. That's it. Let's move on to the next problem. I would like you guys to try this on your own and then check back to the video to see if your answer was correct. Alright, so a drone is launched off of a platform and we're given the function that tells us the height after t seconds. So here's the function that we're interested in. We want to factor this function, so we're going to have to get t by itself. So negative 2.7 t squared plus 13.5t plus 64.8. In order to get t by itself, well, we have to get rid of this negative 2.7 right here. So let's divide every term here by negative 2.7. Negative 2.7, negative 2.7. Right, we can use our calculator skills here to figure out what these numbers are going to be. So we're going to end up with t squared, and let's see, 13.5 divided by 2.7, 13.5 divided by 2.7, we get negative 5t, and then 64.8, let's see, 64.8 divided by 2.7, we get 24. So minus 24. Alright, we want to factor this. So we're going to take our simplified function and set it equal to 0. So let's look at this last number, negative 24. So we're going to make a list of everything that multiplies to get negative 24, negative 2 and 12, negative 3 and 8, negative 4 and 6. We're trying to add up to get negative 5. Don't forget that negative. So if we add negative 3 and 8, we get positive 5, but once again, we want negative 5, so we're just going to have to switch these signs here. So the factors we want to use are positive 3 and negative 8. So t plus 3 times t minus 8. Now we can take each part and set it equal to 0. So t plus 3 equals 0. We'll take the other part, make that equal 0. T minus 8 equals 0. And we can solve. So subtract 3 from both sides here. We get t is negative 3. Add 8 to both sides here. We get t is equal to 8. Once again, we're talking about the real world. Where's the drone going to land? How much time does it take? We only want to focus on the positive amount of seconds because it doesn't make sense to have negative seconds here. So we want to explain what this means in the context of the problem. We already did that before. So the drone will land after 8 seconds. Okay, now we can identify that maximum point. So we want to take the two answers we found previously. The negative 3, we're going to add it to the 8 and divide by 2 to find that middle point. So we get 5 over 2, which is 2.5. And remember, the answer we get here is a number of seconds. It's time. All right, so after 2.5 seconds, the drone is going to reach its highest point. In order to find out what that highest point actually is, we're going to have to plug 2.5 back into the equation. So let's remind ourselves of our equation. We're going to have negative 2.7 times 2.5 squared plus 13.5 times 2.5 and then plus 64.8. All right, now we can just type this into our calculator. Negative 2.7 times 2.5 squared plus 13.5 times 2.5 plus 64.8. We get 81.675. If you want to, you can round this to 81 point, let's call that 7 meters, because our problem uses meters. Now we want to give a complete sentence on what this means in the context of our problem. So, after 2.5 seconds, the drone reaches its maximum height of 81.7 meters. Lastly, we want to look at that line of symmetry. We're going to say that it's whatever, we're going to say that it happens at 2.5 seconds. So we want the equation of a vertical line here. We can just say t equals 2.5. That is our line of symmetry. That concludes our first virtual lesson. If you could, please take a picture of all the pages and all the work that you've done, and you're going to upload it to Google Classroom. So go to the assignment for this worksheet, and you're going to be able to upload pictures under your work. And once you want to turn it in, you're going to hit the blue Turn In button. Thanks for watching. Don't forget to like and subscribe and smash that like button.